We were talking earlier today, and you were using a toolbox analogy, which I found really fascinating. Can you go into that?
Sure. When we think about analytic methods, we can talk very complex. We can talk about the dimethylamino cinnamaldehyde assay, for example. Yes. So these are the type of things that it gets very confusing very rapidly,
Yeah.
and we don't want to make things confusing. So we think about that as an assay as a tool. So it's a tool to do a job. It's going to tell us some information about a specific component of the cranberries. So the DMAC assay, we'll just shorten it to DMAC instead of dimethylamino cinnamaldehyde. That particular tool allows us to quantify the amount of soluble packs. It doesn't quantify insoluble packs, and it doesn't authenticate packs. It's a tool that tells us how much soluble pack is in a product.
All right. Okay, so when it comes right down to it, what should the consumer be looking for when it comes to cranberry?
Well, they should be looking for as much information as can be provided on that composition. So for instance, if you're going to be consuming or utilizing or purchasing products that have both soluble and insoluble packs, you would like to see on a label or a specification sheet or a certificate of analysis the quantity of soluble packs reported by the DMAC tool or insoluble packs. And there's another tool for that. We refer to that as a BuOH-HCL tool or assay. So the two of those together are going to give you the information on how much total proanthocyanidin is present in your product. Other tools could be fiber analysis or protein analysis or oil lipid analysis. That's building this portfolio of knowledge around the product. The more information that's on the product label, the more informed the consumer is.
And price point, does that make any difference if people are in a supplement store and they see a product that's, let's say, $30 compared to $20? Should that be something, a factor that they look at?
I think it should be, but with a caveat.
Okay.
That price should be related to how many doses or how much of the active constituent is present per dose.
Right, so if it's saying take 4 capsules as opposed to 2, you're not getting as many capsules, or you're paying more for, I see what you're saying.
Right, so you're asking if there's 36 milligrams in 2 capsules, 2 500 milligram capsules as a serving, and that's at price point A, and my other product I need 20 capsules to get that equivalent. Is that a 20-fold difference in price or a 10-fold difference in price? And is it worth that price differential? Again, you have to pick up the package, turn it around, and look for that labeling.
And what about a choice of standard reference materials?
Well, now we start talking about quantity.
Yeah.
So we ask how much soluble pack is present or how much insoluble pack is present in a product or a combination of those. And what we need to do is set ourselves a reference. So if we were going to calibrate a scale, we'd put a known weight on that scale and we'd say, this is 1 kilogram, we're going to calibrate. Right now in the marketplace, the majority of the analytics or tools are using a standard reference referred to as an A2 dimer. This is a procyanidin A2 dimer. This is, think about 2 building blocks connected together. So that gives you a specific response. So in the case of DMAC assay for the quantification of soluble packs, the more of the packs there you see, the darker a blue color will form.
Okay.
So it's a colorimetric reaction. And the A2 standard is giving you the relative amount of color. So we correlate the color to the standard reference material. Now, interestingly, the rate of that reaction is different from a dimer to a trimer to a tetramer to a pentamer. As the chain length grows, the amount to color changes. So what we're getting at here is that an A2 dimer tends to underestimate the total amount of proanthocyanidin by about 4-fold. We can combat that by developing and deploying a standard reference material that's reflective of the natural packs that are present in the cranberry. So you can do that in a laboratory. You can produce that standard reference material that's superior in its ability to give you an accurate readout. I think it's important to say that whether it's an A2 dimer or what we refer to as a CPAC standard reference material, as long as you're comparing cranberries to cranberries, A2 to A2, you can compare between products. Not everybody in the market has adopted this improved standard reference material.
Thank you so much for joining us today. Fascinating stuff.
Thanks, Jennifer.